Okay. Well, good day, everybody, and Happy New Year. Welcome to the 2022 DSUA webinar series. We're going to kick off the 2022 series here with a SDA End Users Roundtable. So at the end of 21, we actually had a roundtable discussion on CDS and NID technologies and one on DSI, and we got a lot of really positive feedback on those two sessions. So we got another treat for you here. We've got some very experienced and well respected individuals on the call today to talk about various SDA topics and concerns and just whatever comes to mind. So if you want to go back, you can check out those old webinars as well as the ones we've done over the past 2 years on our YouTube channel. We have a really catchy name, Dry Scrubber Users Association channel. So, you know, be a hard one to forget there. So you can check that out and catch up on any of those old past episodes we have. Before we get into the actual meat of the webinar here, I need to give thanks to our sponsors because without them, none of this would be possible. We have, as far as platinum sponsors go, we have Lawast North America, IGS, Gecko Robotics, ReadyCam, RPM Solutions, National Filter Media, GE Power, Mississippi Lime, and Duramar. For our gold sponsors, we have Reaction Analytics Solutions, Primex, US Lime, and Noltec Systems. And for the silver sponsors, Leckler, Atlas Carbon, and Carton Fujikan. Your participation is highly encouraged during this webinar. So at the bottom of your screen, you'll see a Q&A button. You'll click that, and in there you can actually ask your questions, and then we will read those questions to the panelists and respond to those for you. Also, at the end of this webinar, there will be a survey that you'll receive. I believe it happens at whenever you click leave or whenever I terminate or come to the end of the webinar, you should get a window pop up. I ask that you complete that survey because it helps us, you know, kind of get a plan for 2022, what everybody's interested in, and just help us to establish a path forward for this year. Assisting with today's webinar, we have Mitch Lund, the bearded mystery man. Yes, I know the beard threw you probably from past webinars, but he's back with us again today, the different version of Mitch. And we have Kurt Bean. Mitch was an advisor on the DSUA board. Kurt has actually been on the board for several years now, and he did a webinar last year with us, so he's been around for a while. You know him, you love him. And Kurt, turn it over to you, bud.
Thank you, Travis, and welcome. Good morning, everybody. I'm Kurt Bean from Mississippi Lime. I appreciate everybody's attention today on this roundtable discussion. We've got 3 individuals from the SDA world, and they are Darryl Jacobs from AEP SWEPCO, John Kersch from NAES, and Rodney Sauder from TVA. And we'll go through and have each of these gentlemen give a brief introduction and then discuss kind of a brief overview of what their air quality control system is for the SDA. So we'll start with Darryl.
Yes, sir. Thank you, Kurt. So, like I said, I've worked for AEP SWEPCO at the John W. Turk Power Plant. I'm a mechanical maintenance supervisor here, and I've been at the plant since startup. We commissioned in 2012, and I started out as a planner, and I'm now supervisor over mechanical maintenance in the SDA scrubber area. We have a B&W scrubber, and I handle everything from the air heaters back to the stack in mechanical maintenance.
Okay. Thank you, Darryl. John?
Yeah, I'm at Carneys Point right now. We have a sister plant, Logan Generating, which is just 8 miles up the road. And I was there for about 18 years, and I've been down here 4 years. So the 2 plants are sister. We share a lot of staff, a lot of maintenance folks, operators, engineers. And as a result of that, I have become familiar with both sides. Logan has an ABB design scrubber, and Carneys Point with its 2 boilers has a B&W scrubber. So done a lot of improvement work over the years. We've worked with Primex quite a bit to optimize the process. And just recently here at Carneys, we had an issue with thinning walls on the scrubber, which we repaired. So I think we're going to talk about that a little bit later, though. So that's it.
Okay. Thank you, John. And Rodney.
Hey, my name's Rodney Sauder. I'm a lead shift operations supervisor. And here at the Shawnee fossil plant with Tennessee Valley Authority. I've been with the plant. I've been with TVA since 1999, so going on 23 years. We got we're a 9-unit station. All of our units are rated about 134 megawatts. We burn 100% PRB. We have B&W boilers fired by 4 ball and mill type pulverizers, but only 2 of our units are scrubbed. The only 2 units that we had to have scrubbed were units 1 and 4. So we installed 2 Alstom or GE SDAs, dry scrubbers. And each one of those units also has a Riley Power SCR. After the SDA, the flue gas goes through our fabric filter or bag house that was already existing. We've already had the bag house since I think back mid 80s or something like that. So it was a previous install. And I guess that's about it. Our scrubbers, we use 3 centrifugal atomizers. So it's a little different than some. I guess we're not injecting. We use atomizers instead of direct injection. And we're also a recycle lime. We also use recycle and lime. And the lime that we use is a hydrated lime also. So that makes it's a little bit different. I guess that's about it.
Yeah, that's the interesting thing. You don't slake. You use hydrated lime in solution. So hopefully we'll have some questions for each of you, and we'll start. Travis, you can have the floor for the first question, and we'll go on from there.
Sounds good. Thanks, Kurt. Thanks, guys. So in the last 2 webinars, we kind of led off with, the big elephant in the room always is, how has COVID affected you? How has it affected your plant, your staffing, your lead times for parts, and getting labor in? And just interested to hear your thoughts on it. Let's start with Rodney.
Yeah, I'd say we're probably no different than anybody else. I mean, staffing has been a major problem, especially, on the onset of the whole COVID thing. But, we're a power plant, we got to keep running. So we've just managed. I mean, I don't know any other way to explain that. I mean, there has been times where we've had practically sent whole shops home, because of exposures. Lead time on material, I'm sure everybody's in the same boat on this. Lead time definitely has been challenging. Lead time on everything from turbine parts, we've had to extend outages to environmental control chemicals. And we've struggled to get that stuff in because of trucker shortages and supply and demand. Supply and demand on some of these chemicals because of some of the everybody's going through these same environmental changes and regulations. So it seems to me like, the supply and demand on a lot of the chemicals and stuff that we're having to buy in now has gone up. So that coupled with the trucking shortage has caused some serious problems, I guess, challenges, I should say. Yeah, and I guess that's probably about it. The staffing, like I said, staffing has been a challenge, and I'd say that everybody's in the same boat there. But we have managed. We haven't had to do anything too drastic. It's just a matter of running thin at times.
Okay. Thanks, Rodney. Darryl?
Yes, sir. So I consider my team to be pretty blessed. We've had some out at times, but I hadn't been real scarce. I have a crew, a team of 8 on my crew, and usually it's a maximum of 3 or 4 out. So we do kind of like Rodney, we manage with the team that we have, prioritize work, and work through our opportunities and try to keep everything running. As far as lead times, I have seen the same thing. Longer lead times, higher prices, but we have not been put in a pickle yet as far as lead times. But my lead times, some of them are out 12 weeks or more, and so we just have to deal with that. Staffing, like I told you, we have 8 guys here, so I've been, like I said, I've been blessed on staffing, so not too bad. We keep the work, keep everything running. That's the main thing. That's all.
Thanks, Darryl. And John?
Yeah, we're probably pretty much the same as everybody else. We've had since the start of the pandemic. They sent the admin staff and the engineers home for a couple of months, and then the engineers came back over the summer, and then some of the folks stayed out for an entire year before they came back. So just the typical dealing with Zoom meetings or Teams meetings or whatever with a lot of folks. Both ops and maintenance, had been hit with guys being out with COVID, and we're very fortunate in that we share a lot of staff between the 2 plants and that they're close by to each other. And so, there's a lot of extra overtime being worked to cover, when we've had a whole shift of, operators wiped out, until they got clear of everything. So that's been one of the tougher things. And, same as everybody else, delayed on parts getting in and, push some outages back. But I'd say probably our single biggest issue over the entire pandemic has been coal delivery. Carneys gets its coal by train, Logan gets its by train and barge. And excuse me one second here. We've gotten to the point where we actually have trucked coal between the plants. It's gotten that bad. Like the pile has gotten so low that we're forced to truck coal between the plants, which is just bizarre. That we've reached that point. And a lot of times, what happens is, say a lime delivery is coming. The lime supplier, they have the ability to remotely check the lime silos, the levels in the lime silos, and depending on which plant needs it more, there may be only one truck coming and it'll go to one plant, versus the other. So that's probably been the biggest challenge and headache for the whole pandemic.
Wow. Thanks, John. Kurt, you got a question?
Sure. For all of the panelists, with today's demand fluctuations and load swings, what are some things that you do at your plant procedurally and with equipment to allow your SDA to operate across this site recycling loads? And we'll start with Rodney.
I don't think we've really had to make any changes. We fluctuate. We'll swing our load anywhere from full load, 134, 35 megawatts, And at times we do take them on down to our emergency minimum. The main challenge, I guess, on the scrubbers is when we're down that low on load for an extended period of time, and we're having to come down to just maybe one atomizer running. Then we get a little bit of uneven, unbalanced flow through the reactor, and we'll see some wall buildup and stuff like that. I think probably is contributing to that. But other than that, well, and flow rates, slurry flow rates and stuff. Whenever we're down that low, if valves are starting to get washed out, then at one time we were over injecting a lot. We were down on low load for a long period of time, and some of our flow control valves were washed out a little bit. So we were over injecting. That caused us some plugging and some buildup and stuff. But we really haven't made any adjustments though, or we just keep on trucking.
So what, Rodney, what with your SCR, what dictates your minimum load or your minimum operating temperature?
What
sets that? I don't know what it is, 50, 60, 70 megawatts. What keeps it from going lower?
Oh, what keeps us from going lower? The unit just gets unstable. Anything below 45 megawatts, and we're liable to lose the fires in the boiler.
All right.
The units get too unstable.
Okay. Thank you, Rodney. Darryl?
Yes, sir. So I'm kind of like Rodney. We have not changed a whole lot, but we've tried to improve. We have hired Primex to come in, do some efficiency testing. We've worked on our lime slakers, worked on our water heaters for the lime slakers. I know they have tried to optimize on temperature control on the outlet of the SDAs to help control our conserve lime, and that's we did a flow test with Storm to check our flow test on the SDAs, and come to find out our SDA was not had inlet baffles on the inlets that was not installed during construction, and we installed inlet baffles back in there during our last outage and got our split correct. We're back to the 60-40 split that we should have been when we started, but when we did our flow test, we found out we was at 40-60. So we've just done some changes because of that. Not a lot of changes because of load, just trying to be more efficient. Our high load is 675. Our low load is 350, and that is the low load is because 350 because we have a ultra super critical boiler here, and flow through the boiler. You have to keep the load up pretty good.
Okay. All right. Thank you, Darryl. John?
Yeah, we typically we're either going to run at minimum load or get dispatched to full load. There's really no in between for us, as dictated by the power purchase agreement. So we generally know the day ahead what our dispatch is likely to be, and if it's forecast for a day or several days in a row that we're going to be up on load, a lot of times they'll cycle through the bag house and make sure that all the bags are in good shape. And then on the scrubber side, our biggest issue is we don't have recycle. If we lose recycle flow, we start using way more lime than we should be. And a lot of that has had issues at the lower loads with the recycle piping clogging up with the recycle, to the point where they got to bring in an outfit to blast out the piping. And if they can't do that, we actually just replaced a whole bunch of it last fall. And once we do that, she runs like a champ. So those are probably the biggest things. We had all the same discussions that have happened before. Should you be putting hose in place of the recycle piping so you can just chuck the hose, when it gets clogged up, as it's the buildup is going to happen no matter what you do. So just something I think that everybody has run into that has recycle at their plant.
Okay. Thank you, John. Travis?
So I guess this is a bit open-ended. I'll leave it, you guys can address it the best that you can. Well, I guess what is the biggest problem you're currently addressing at your facility, or are there any relatively new regulations basically that may be causing you some headache? Let's say, like, for example, CCR in relation to your recycle solid material. John, do you want to go first?
We don't have any issues other, regulatory wise. They were addressed kind of years ago. They used to landfill all the fly ash back in Pennsylvania, and then Pennsylvania changed their laws, and so now it's landfilled locally. If we have a lot of runtime, and obviously we're making a lot of ash, you're kind of at the mercy of the landfill being open. It's only open certain hours, or if the weather's bad or holidays or whatever. And we've actually been forced to dump it on the coal pile and then retrieve it later.
How far is your landfill from your plant?
It's less than 10 miles.
Okay.
And of course, it's taking ash from both plants at the same time. But so it's not bad, but it can be a headache at times.
Yeah. Okay. Thanks. Rodney?
Yeah, we've had several challenges. The CCR rule, we had to close out our ash pond and our dry stack where we stacked our ash. So we had to close both of those out. We had to open up a processed water basin and a bottom ash dewatering facility. We had to install that, and we didn't have one of those before. So we had to dewater our bottom ash, and then the effluent from the bottom ash water goes into our processed water basin. So we got to treat the water there. Our station sumps discharge in the processed water basin because that comes in contact with ash. So we gotta treat all that out of our processed water basins, which are considerably smaller than our ash pond. So we don't have as much retention time as what we used to have. So we really gotta stay on top of it and use a lot of chemicals. Our chemical usage and the amount of chemicals and the types of chemicals we're using, that's gone up. Well, we didn't even use them before. So it's untold how much extra that's costing. So yeah, the bottom ash dewater and the processed water basin. And we also had to acquire, since we don't have a dry stack, we had to acquire some land to landfill our ash. So we were lucky in that respect, as opposed to John's situation. There was some land right adjacent to our reservation that we were able to purchase. So then we just had to install a haul road to get our ash back there. It's about a 3 mile one way, 6 mile round trip for our trucks. So not, incredibly long distance, certainly better than what John's facing. And plus our trucks stay on site. So that's definitely a benefit. And specifically with the scrubbers and the challenges that we're facing now, it's got more to do with the ELG, or effluent limitation guideline, that was issued by the Kentucky State, the Kentucky Department of Environmental, what's it called, system. But KPDES has put out a ELG, effluent limitation guide. So it's we're gonna have to take our bottom ash transport water, and we'll have to recycle that or recirc it. So we got to install a recirc system now. So we're getting close to a zero emission plant, but not 100% zero. But in doing that, and to meet these ELG rules, the ELG and the CCR rule, before we would take, if we were coming off on an outage or something like that, and we had to drain our tanks, our slurry tanks, we could just drain those into our bag house sump, which would discharge out the ash pond, and all that was fine. We can't do that now because of ELG. We can't do that. Causes so we can't do that. So we're having to we had to do some research, try to figure out what alternatives do we have. We're working with one of our vendors, UCC, has helped us come up with a design, and we installed just a prototype, if you will, just to give it a try this past summer during one of the outages, where we would take our slurry, our recycled slurry, and our lime slurry, and cycle it through this system. And basically, we just took the slurry, put it in some tanks, some frac tanks, raised the pH, then hit it with some coagulant, some polymer, and got all that stuff to settle out. And then we pump it out into some geo bags for it to dewater. And we did all that out on our bottom ash dewatering plant. So while it was dewatering, all that water just went right back into our bottom ash dewatering, where it's further treated. And the process worked really good. So a good thing for us is we had also installed an outage wash system, which includes a filter press and some slurry tanks or sludge tanks. Come to find out, I mean, our boilers, when we do our boiler washes, we really don't produce that much sludge, that much product or whatever from the outage washes. So our filter press was never even used. We haven't even used it yet. But it looks like we might be able to use that for getting rid of this slurry. Might be able to use that to dewater the recycle and the lime slurry. And if we do that, that's going to help us out immensely. And it's just a matter of treating with some chemicals and getting it filter out. But that's the challenges that we've been facing.
Okay, thanks. Sounds like you've had a few, but you got a path.
Yeah, I mean.
I appreciate that, Rodney. This is Mitch, guys. I think we got a question from the audience too, and I think this is in relation to John. I think what you were talking about before. I can't really tell, but the question is: do the recycle issues seem to occur at low load, full load, or both?
Yeah, I would say both. I mean, the low load end is kind of where the the recycle flow is looping, back to the tank. And then at the full load side, it becomes an issue of getting enough of the fly ash to get to the recycle tank to not thin it too much. They're trying to run it right around 40% solids. They found that that's the best, or let's just say the maximum that we can get away with, to improve the scrubber performance. And one of the problems that Carneys has that Logan doesn't is it only has a single recycle tank. Logan has two recycle tanks. So it's a little bit easier up there if you have some equipment problems or pump problems or what have you. There's a few more options, but yeah, it happens at both ends, high load and low load.
I appreciate you clarifying that, John. Great question from the audience. Trav, back to you.
Thanks, Mitch. Yeah, and to the audience, feel free to ask any questions you may come up with as we progress. Darryl, same question to you that I had asked to the others previously.
Yes, sir. So not many problems here. We have a submerged flight conveyor, so we're not dealing with dewatering our bottom ash. It goes straight to the landfill. Our landfill's on site. Our fly ash, it's dry. We transport it with trucks to the landfill. I do have, I have a recycle ash silo that I reuse my ash, and then what I don't use goes to a waste ash silo, and that gets transported to the landfill, which is just within a half a mile, quarter of a mile of the plant. And we have installed a new dry ash removal system. It's possibly to sell our ash. We have not sold any ash yet, but we do have that opportunity if it opens up. But not many problems there.
Okay. All right. Thanks, Darryl. Kurt, you got in the question?
I'll start with Darryl while he's hot. What type of improvements have you made or tried to make to the quality of your slake lime slurry? And what have you seen, kind of steers that performance, any performance benefits or performance detriments?
That's a good question there, because we've been working on trying to be more efficient with our lime, cut our lime usage. Like I said, we've hired Primex to help us with SDA efficiency. We set goals of a 5% reduction of our lime in 2020, and we also had the same for 2021. We reduced our lime in 2020 by 6.3%, and in 2021 we reduced it by 8.3%. We did that by working with our slaker temperature. We were having trouble with the slaker coming up to temperature, and we found out that we had water heaters that were dirty. Our water had sediment that had laid out in the water heaters, and it was cutting the efficiency of our water heaters, making temp, especially in the wintertime. We cleaned those. We tried to get the temperature to where we were up to slaking temperature by 15 minutes. And we also had we put cleaning ports on our feeders to ensure we were getting the right amount of lime in there. That is cleaned by just air lamps, and because we were getting buildup in between we have like an airlock system there, airlock valve, and it was getting buildup in between the rotor blades, and we put that in. We got that to where it gets cleaned out. So, but like I said, we also work at trying to keep our temperature on our inlet and our outlet of the SDA. We control it in the winter months. We set it down to 168 degrees, and our summer months we set it at 180 degrees, and this helps reduce our lime usage. And it's, like I said, it's helped us meet our goals and get over our goals on that. But lime usage was a big deal, and activated carbon, we're trying to get more efficient for that now too.
Great, thank you, Darryl. John?
Biggest issue we had on the slakers was identified that we had a potential safety problem, them getting too hot. And part of, I guess, Primex's package that we have, they do a lot of monitoring via Pi. keep an eye on things, and they identified it as a potential safety concern. And so we work with them, and we have an outside controls contractor that we use quite a bit, who has the ability to remote into the plant site and make changes to the PLCs. And so kind of like operations, engineering, Primex, and this outside outfit called BTG Controls kind of work together. And one of the things that we did was we added flow meters to the control system. Prior to that, they just had a flow switch to identify that you had water going, but you didn't know exactly how much water was going into the slakers. And these are the, the drum type slakers. So, we added that equipment in, incorporated into the control scheme. And, now the slakers run like champs. No issues, no safety concerns. It's all pretty much behind us.
Thank you, John. And finally, Rodney, as we said, or as you said earlier, you don't have slakers. So what, if anything, have you seen with your hydrate makedown system as a scrubbing chemical?
No, yeah, luckily we don't have slakers. We pay a premium for our hydrated lime, but as far as I know, I mean, our lime system is pretty smooth. We do have some pluggage issues at our wetting box, but lime unplugs fairly easy. I think it's not a major issue, but other than that, I don't think we've had any trouble with our slime or lime.
Okay. Great, that's good to hear. All right, thank you, Travis.
Thanks, guys. So kind of, this is a question for, I guess, Darryl and John for the most part. Kind of piggybacking on that slaker topic. Have you guys noticed any kind of correlation between the amount of grit that you're finding in your slaker and like your atomizer plugging or vibration increases? Are you seeing any correlation there at all? I see John shaking his head.
Yeah, honestly, no.
Okay.
I think the biggest issue, Logan has 2 scrubbers, 3 atomizers in each, and it's very easy for them to swap atomizers around. Whereas at Carneys, you have the single atomizer in each scrubber, and you get to the point where you're at that maintenance window, if you will, by hours of runtime, and it makes it tough to swap them out online. You got to do a lot of finagling with the unit and back and load off and all. But beyond just normal wear and tear on the nozzles, from the recycle and the lime, there's really nothing that we've seen that the grit becomes an issue. We also have strainers in front of them too, so that I think that probably helps quite a bit with clearing out any of the bigger stuff.
Okay.
That was the strainers are on both the recycle and the lime, and those were retrofit on. They were not original equipment.
So your system, John, you've got your recycle slurry and lime slurry both feed up to the penthouse individually, and they
Correct.
mix in the. Okay, all right.
Correct. Yeah, and that's at Carneys. They join together just as they're getting ready to go into the atomizer. Whereas at Logan, they have a head tank system, but the lime doesn't join that until right at the end of the process. Like the recycle comes in and then the lime comes in. So it's for an individual atomizer, they're feeding the lime in. But again, there's really nothing other than normal stuff that we've had issue with. Sometimes it gets chunky, and that was part of the reason for the strainers, to be added. And then one of the things they do whenever we do have an outage on a unit, they'll replace all the hoses that lead from like the strainers, down to the scrubber, so that buildup that does happen, it doesn't like break off and then follow through.
Darryl, have you seen any correlation between those?
So we don't have any pluggage. We haven't had any in a while. We did have a little bit when we were trying to cut back on our lime. We started making concrete, and our head tanks would build up. We'd get, I mean, we got to where we had possibly 5 inches of buildup on the outside of the head tanks, and also inside our hoses. We have a line and then hoses that run down to the atomizers, and they were getting a thick scale on them, and they figured that out real quick that we can't cut back on our lime as much as they wanted to, and so once we got our lime back up to the right consistency with the ash, we were not making concrete there anymore. So that's the only pluggage that I've seen. I didn't have any problems with atomizer pluggage in the wheel. I have had some problems with buildup in my recycle ash slurry tanks, and that was we dealt with that by, we found out that we weren't agitating enough in the tank, so we added onto our baffles on the sides that helped agitate it. Other than that, that's only buildup or pluggage that we've had real bad. We did now on our when we put those we put the inlet baffles in on our SDAs. We were having fallout in the SDAs. You know, we were having build up on the walls, and we were having fallout pretty often. And but since we put those baffles in, it's helped with our fallout. We don't have any hardly any fallout except for when we shut down.
Okay. All right. Thanks, Darryl. So Rodney, as we've said, you know, you obviously you don't have a slaker, but have you seen anything that may you correlate any kind of atomizer pluggage or vibrations to?
To lime specifically?
Yeah.
Is that what you're asking? No.
No. Okay. All right. I think to kind of piggyback on and build onto this topic that we're talking about. I mean, obviously atomizer pluggage vibrations is always a question that we get at this conference every year when we had in person. I'd like, could the three of you kind of give a rough idea of what your maintenance interval is? Like, I mean, how many weeks are you going between regular atomizer rotation, and how long each time you do an atomizer swap out does it take? I know there's a couple different systems out. You know, some of you have single atomizers. Rodney's got 3 per vessel. So start with John.
I'm thinking at Carneys, they've gotten it down to the point now with the lockout tagout, you know, as being part of it, and all that they can do an atomizer swap in less than an hour.
Okay.
Logan, it doesn't really matter so much because they always have a spare hole that they could stick it in, you know, and swap them out. So it's not really that big an issue. As far as the interval goes, I'm trying to brain fart the number of hours, you know, that they have set up, you know, as a PM on those. And I'm going to have to I'll have to circle back to what that is. And the guys, they try and follow that as close as possible, you know, but I mean, occasionally you're always going to have something else happen. You might have an oil pump go, or, you know, the disc get out of whack, and you're going to have to pull it just because of that.
Yeah.
We have learned that the atomizers at Carneys are a lot more forgiving than the ones at Logan, you know, when it comes to vibration. And it's interesting when the operators go back and forth between the plants, like they start to notice stuff like that, you know, like, well, at the other plant, you know, they don't have this problem. Yeah. So I think that's about it.
Okay. Rodney?
Yeah, I think we've got our atomizers on a monthly PM basis. I might be wrong on that. I think we're on a monthly rotation. So like you said, we do have 3, so we can always take one out and rotate them around. Some challenges that we had in the past. Well, a couple things. One, the way our switch gear and everything is set up, and to stay within our tagging, what we call our clearance procedure, we have to ground our breakers when we rack them out. We ground the atomizers. So we stay within our grounding procedure, and that makes tagging them out. That takes a little bit longer. So like John was saying, I think John said that he could you want to turn around in like an hour. Not us. I mean, you're looking at just to get one tagged out and ready to work probably takes 4 hours. So you're looking at, we can only do one atomizer a day. That's about all we can do. And when we have in the past, it's a learning curve. But one of the problems that we have had is, like, if we've had an atomizer tagged out, but has not been removed from the hole. If we haven't pulled it, but we've tagged it out, maintenance is if they're on the clearance, and unbeknownst to them, they're holding the clearance for the atomizer. It's still in the hole, so operations can't do anything with it. I don't know how the other sites do it, but operations doesn't control pulling the atomizer. That's a maintenance task. So we don't do that. We leave it up. Maintenance has it. They've tagged it, or we've tagged it out for them, and they have control of it. And so it might take them some time before they're waiting on parts or whatever it might be. And the atomizer's been left in the hole while it wasn't spinning. And then you get into some vibration problems. Then if they're not actually planning on pulling it, try to put it back in service, and it would trip right out because it's had some buildup on the disc. Other than that, I can't think any other challenges or problems that we've had right now.
Thanks, Rodney. And Darryl?
Yeah, so we have a 4,000 and 8,000 hour PM. Our 4,000 is changing fluids and just inspecting the machine. 8,000 hour is our total rebuild. And as far as pulling it, we can usually get it done in an hour or less, and we've set up a procedure where our operators they hold the clearance. We don't hold it. We just sign on to it once they get up there. So they set the clearance up, they bring it up, and we sign on to the clearance, pull the atomizer, put it back in, and then sign off the clearance. So it's kind of streamlined pulling the atomizer, so it helps a lot.
Okay, thanks. Kurt?
So Darryl, you said 8,000 hours?
Yes,
You change atomizers? So that's a long time. So the atomizers run that long?
So we have a 4,000, 4,000 and an 8,000 hour.
Mm-hmm.
4,000 is like I said, the oil change, and that requires pulling the atomizer in.
All right.
I mean, sometimes we have trouble with the flooding. We haven't had a lot of trouble with it lately, but if we have trouble with flooding, we see we have a high level in the lower sump, we'll know that we flooded, that the atomizer's been flooded, and we'll pull it and change it out. But normally 4,000 hours is what it runs.
All right, thank you. We have a question from the audience. And the question says, for those with rotary atomizers, how do load and flow changes impact vibration, and how do you mitigate high vibration? I'll start with Darryl.
Okay, so we do have rotary atomizers here. so far we have not had any trouble with vibration at high, low, low load. So we don't have trouble with vibration that much.
Okay, John?
And it's an occasional problem. And some of the stuff I was talking about earlier, I think recycle seems to have the biggest impact on that at both plants. Logan's a little more sensitive to it than Carneys is. And usually, while you guys were talking, I looked it up. We do a 1,500 hour PM on the atomizers here at Carneys. And of course, that's not always possible, depending on if we're being dispatched or whatever, they might have to postpone it. But as far as vibration goes, usually if we have to, we'll go to all line, and that a lot of times will eliminate the issues, at least, on a temporary basis until we can get an atomizer swapped out.
Well, I mean, what
as
causes,
far as load,
what causes the vibration?
a lot of times it ends up becoming wear, on the nozzles, and the disc becomes unbalanced because of that, or you'll have some buildup. I keep comparing the two. The discs at Carneys are a lot smaller, more compact, whereas the discs at Logan are a much larger diameter, and they tend to have more wear issues. And the in and out nature of the atomizers at Logan, a lot of it depends on the operator. Like when they put an atomizer into service, they really have to bring it up slow. They just can't, hit auto and just say go. It tends to ramp it up too quick, and then that causes vibration problems. And I see Darryl's head nodding, same stuff like that. And that's the ultimate pissing contest between maintenance and ops all the time about how you operate the equipment. Because once the atomizer is sitting there and it's spinning, and then you start loading it up, if you bring it up slowly, usually you don't have an issue. But if you just, like I said, sometimes the operator is, I'm going to say lazy, the operators in the audience won't be happy, but they'll just hit auto and it'll ramp itself up, and it's too fast. And that'll cause a problem.
All right. Rodney?
Yeah, I think early on our atomizers, our scrubber has only been in service since 2018. So some of the problems some of the other sites might be having, we just maybe haven't experienced yet. Maybe it's still coming, but we did have some vibration issues, as I mentioned earlier, just due to buildup on the disc, leaving the atomizers in the hole when they weren't running. So that caused us some problems, and just here, I think last year, I started hearing from our maintenance department that our discs are starting to show some significant wear, and those were the ones that had the significant wear on were causing some vibration issues. But other than that, as far as I know, we don't have any vibration problems.
I do have a question. How many nozzles do y'all have in your wheels? I have 12 in mine. Some of them have 8. That could cause a problem, I believe. It just depends on how your flow is to your wheel, and you're getting all your flow out of your wheel. You're not feeding it too fast, in other words. But I have 12 nozzles in my wheel. And so we monitor the wear on our nozzles every 4,000 hours. When we pull it out, we look at our wheel nozzles, make sure everything's all right. But that could make a problem with vibration. And I know John talked about them ramping it up too fast. We got with DCS here at the plant, and made sure that they can't do that.
Thank you. Go ahead, Travis, if you would like to ask one.
Yeah. So we'll go ahead. I guess we've talked a lot about vibrations and slakers and things. Do you guys have any, or what is the most recent significant upgrade modification you've had to make, or that you may have planned in the next year or two? I know John has a pretty interesting situation that he probably would like to share. I'll just start with John.
And hopefully when I do this share, pictures are always easier to talk from. We won't I won't lose anybody. We had a so let me see if I can share this here. You guys seeing the picture? Give me some feedback. Okay, so this past spring, back in May, we had an outage. It was a major outage for us in that both boilers and the turbine were all down at the same time. And something that we had wanted to do for a while was to check the scrubber walls that had not been lined with stainless. There's a band here from previous outages where we put in stainless liner plate because the walls were corroding. And I think anybody that's been to a conference at some point in time is kind of aware of the plant out in Wyoming that actually collapsed one of their scrubbers. So that was not the concern here at the mid band there where the spray line is. It was the walls above and below that were not lined with stainless. So we brought the Gecko robot in, and there's just another shot here. You can see pretty distinctly here where it looks like it's kind of rusty above and below that stainless band that had not been touched at all. And so the Gecko robot comes in and he does his runs around those bands, and he comes back at you with some UT readings all around the scrubber. And this top picture, if you will, any place that it's white, that's where the stainless was. So you can see where it's kind of like choppy and stair-stepped and all. And just by the thickness readings that we were getting, there was a lot of concern that the scrubber could potentially collapse at either one of those bands. They were both below what B&W later determined as being a safety factor that was going to hold up. With the plant having a projected life of at the time just of another 3 years, it was kind of like a what do you do kind of thing. So we formulated a plan with B&W to do some exterior cladding, and we also looked at doing some temporary supports from the outside. That was one idea, to take the load off of the walls of the scrubber. Another idea was to support it up at the top, and then you can see, the cladding there was 13 courses, if you will. And so the repair fix was to do 3 at the top and a couple at the bottom, and then any place else that we had found thinning. Problem became there was a concern about doing this repair work online, because we discovered it during the outage, but we didn't come up with a repair plan until late into the summer. And so I had used Hake Barnhart in the past, and they came back at us with this modular lift tower idea to externally support the scrubber. And the biggest thing is that could go in right away. There wasn't a big delay there. And what we ended up doing was there's 12 roof beam supports that go around the scrubber, and B&W was able to determine if we put extensions on these that we could support the scrubber vessel while we did the cladding repairs. And here's one of the those beam extensions. And then what they would do is shackle the cable to that. And we actually ended up going right through the duct because the unit was off at the time. We just went right through the duct to support it. And so within this is an exterior shot of them setting it up. And of course, you had it completely scaffold around the scrubber. We stripped all the insulation and lagging off, found a lot more areas that were thin than we were expecting. So the work scope definitely grew. But it was kind of a unique solution to the problem. They have these things called pugs, pull-up gantries. So basically, once the shackles are all in place all the way around at the 12 points, they jack it up to take the load. And that allowed us to then do the repair work, minimize the risk to anybody doing the work. And we were able to get the units on pretty quick after that. Here's just one shot of the carbon steel reinforcement that we put on. And both scrubbers were pretty much in the same boat. So we did the work on both of them. And then this is a shot here where they're both up and supporting the structure while we're making the repairs. So let me see if I do this right to figure out how to stop sharing it. Hang on a second, guys. My screen has gotten small here. All right, there we go. All right, we're back.
Yeah.
So that was kind of a quick, long-winded discussion, about what we ran into here. And it was not something that we were expecting. It was, when we were originally going to run the robot around, we figured, okay, we'll just confirm that, that we still have meat left on the walls and it'd be no problem. They came back with the walls are thinning and I'm like, hey, we got a problem. So we ran the unit until we pretty much formulated a plan and then shut down to do the repairs. And then once, like I said, once we felt we had the upper bands reinforced enough, we restarted the units with the support still in place.
Okay.
So it's kind of a unique solution to not an uncommon problem. These the scrubbers had been reinforced back 2006, 2008 timeframe with the stainless. And then they were never, nobody ever thought about it again. Changes in management, changes in personnel, changes in ownership. I said, well, why don't we just be safe and go check it? So.
Thanks, John. So curious, I guess two-part. We've also got an audience question about this too. Timeline. I mean, how long did it take for this project to go from when they first mobilized to where you were ready to run again? And then the second, okay, go ahead.
Go ahead.
And then the second part was the audience question is: have you installed any sacrificial corrosion protection after or as part of the project?
No, nothing sacrificial. We did just carbon steel on the exterior to build up the thickness of the wall. I mean, we were down to from an original 3/8 wall thickness, we were down to an 1/8 or less, in some spots. So it was, and we when we exposed all the insulation and lagging, exposed the side of the scrubber, we actually found more areas that were corroded with holes, right through the structure and thinning that we hadn't anticipated. The timeline ran roughly from a visit to the site at the end of, I guess, October 1st, end of September, October 1st. We had made a decision to shut down by Thanksgiving. We had both scrubbers supported and we were back online before Thanksgiving. So roughly in the span of 6 weeks, from when we first had a site visit. We actually looked at, bringing in a big crane to temporarily support the scrubber. And then there was lots of issues with that, like where do you attach to, and you know, something that was made to be in compression, now you're going to be pulling on, could the bolted connections handle it and all. So there was a lot of work behind the scenes by B&W to assess it and help us come up with a repair plan. But alternatives, you know, there's other alternatives to support it externally. We're going to take better than 3 months to design and fabricate and get installed. And we would have been down that whole time. So we really cut the timeline in half, easily cut it in half, and price pretty much in half too.
How old your towers, John?
Everything went commercial in '94. And like I said, right around 2006 to the 2008 timeframe, they did that initial stainless band, you know, that a lot of people have had issue with. Our sister plant up the road, Logan, their original design walls were only 3/16 thick, and they were originally going to go with a coating plant there. And what happened is they corroded through, they started sucking insulation in, and it was clogging up the fly ash system. And what they ended up doing there was completely lining the scrubber with stainless, you know, the roof and the walls completely in stainless, you know, put a new cone on the bottom and also a different fix, but that actually happened before Carney's issue. You know, that was like, say 2000 or so, 2001, something like that, that they started having issues, and they planned it around a turbine outage so that they could just do it during a normal, you know, 5-6 week turbine outage. Whereas this, we were pretty much faced with shutting the unit down and having to get the supports in before we can make the repairs. And again, that was all to reduce the potential risk for a collapse while we were doing the work.
Okay. All right. Thanks, John. That's pretty interesting there. Darryl, do you guys have anything significant like that you've either done recently or have in the works in the near term?
So like I said, we installed the inlet baffles on the inlet to the SDAs. It's kind of like a restrictor plate. And we installed extensions on our baffles inside the recycle ash slurry tank to help with agitation. We've installed a dry ash removal system out at the waste ash silo for possible sale of ash. That's about it.
Okay, thanks. And Rodney?
Yeah, I think nothing as significant as what John's had to do, but one of the things that we had problems with early on was plugging in our transport pipes. So we did go and we changed out all our elbows and put the reinforced rubber hoses on those, and that made a significant difference in our pluggage rate. So anybody that hasn't done that yet, I think we've proven it pretty quick that it was definitely worth doing. Other than that, I think we have experimented with 1 or 2 different types of mechanical seals on our slurry pumps. Because we had some issues with our mechanical seals failing. Same to us, like prematurely, whether it was operational issues or lack of maintenance, or it's just a fact of life. I don't know what that ended up being, but we have tried a couple of different kinds. I can't really think of any other significant. Oh yeah, there was one thing. We the dew point analyzer. Initially, our dew point analyzer was installed on the outlet of our bag house. And and it was very erratic. It never worked. So we never could operate in a dew point mode. So what we ended up doing, I think it might have been Primex, I'm not sure who, come out and installed another dew point analyzer on the SDA outlet instead, with some kind of a screen or something to prevent it from getting plugged up from ash. And so we've been operating in that mode ever since, I think, which that's made some significant improvements. Other than that, I can't think of anything else, any big changes.
Okay. Thanks, Rodney. Kurt, do you have any questions there on your list?
Well, Rodney kind of started that with the dew point analyzer, and I guess for Darryl and John, do you have what do you have? Moisture analyzers, dew point, et cetera, as real-time feedback for your process control loop, and what's the good and the bad on those pieces of instrumentation? Darryl?
So we do not have dew point. We do not have dew point analyzers here at Turk. We just run off of temperature. So
Okay.
no problems with dew point.
You haven't seen any no corrosion problems down?
No, sir. We hired Primex to do a corrosion. We did a year-long test on corrosion, and we have not seen any corrosion so far from the inlets of the SDA to the outlets of the baghouse.
Okay. John?
Okay, so let's start with Carneys. Carneys, runs on approach temperature control. They started out with the dew point analyzers on the outlet of the baghouse, so they're in the clean air. More recently, we worked with Primex and we installed some at the SDA outlets, and we had some issues with them trying to get reliable readings, and I think ultimately what we just figured out was that we actually had corrosion significant enough in the scrubber that we were sucking in outside air, and that was messing up the readings on them. So we're pretty sure that that was the root cause of why we could never get them corrected. And that's not an uncommon problem with the dirty probes, especially, or them in general. If you have leaks at expansion joints, or ductwork is corroded underneath all the insulation and lagging, it's sucking in outside air, it's a problem. Up at Logan, we put some of the first ones in of the dirty dew points probes, as we like to call them, and they have a small miniature baghouse bag as a filter in there, and then compress air periodically will clean that. And it takes a little more maintenance effort to pull them out and change those out with the unit on, but it's doable. And up at Logan, it significantly reduced the use of line up there. And there you didn't have much of a choice, because you had two scrubber vessels that came wide together and came into a common baghouse. So you had to have something at the outlets of the scrubbers themselves to be able to control better, depending on what configuration, how many atomizers you had, operating in either one, as opposed to at Carneys, single scrubber, single baghouse, single, final control element. But they're definitely the way to go. You're as you're SUP blowing and you have ambient temperature changes, what have you, they're definitely the way to go. You'll use a lot less lime if you get them in there. And of course, the downside is, corrosion. So you got to keep after that. With maintenance, we do the corrosion coupons like a lot of people have done. It's just that over, the life of the unit, and I'm sure this probably contributed to the problem that we found here in the scrubbers, the lifetime of the unit, a couple mils a year doesn't seem like much, but after 10 years, 15 years, 20 years, it'll add up.
Thank you, John. Travis?
John, just a thought on what you were talking about there. So you mentioned, I forget which plant it was, whether it was Logan's or Carneys, you mentioned you have your moisture analyzer in the outlet of the SDA because you've got 2 SDAs going to a single fabric filter.
Logan, yeah.
Logan, okay. Comparing that versus having like a moisture analyzer downstream of the fabric filter, which is probably going to be lower maintenance as far as the instrument itself. I realize you couldn't do that in order to get individual SDA control. Do you see any problem with somebody doing that? Like even say Rodney, who's got 1 SDA with 1 fabric filter in line. Do you see any issues with end leakage from the fabric filter skewing those numbers from that analyzer?
I'm sure that it's possible too, and the fact that it's further away from the process, you have a little bit of a time lag, before you're getting the readings, but it's not like the baghouse itself doesn't have in leakage at times, where we've had corrosion around the doors, or in the duct itself. But yeah, it's definitely, or an expansion joint. Like I was saying before, all those things will add up. That cumulative effect of that outside air coming in definitely could impact it. But I think just the fact that you would have that temperature, that approach temperature information available, where the dew point is huge.
Yeah.
Well worth the investment.
Okay. So I know earlier, John, you mentioned you guys run around 40% solids because that's where everything seems to be happiest. And Darryl, you talked about the lime savings initiatives that you all have taken on over the past 2 years and the reductions that you've seen there. Have you guys looked at trying to balance a lime slurry percent solids and a mix or a kind of an atomizer feed percent solids with the recycle, as far as what gets you to that most economic operating point and the challenges associated with maybe getting to that point? I'll probably start with Darryl on this one.
So we were running in the 42% density range on the solids, and then after we did the changes with Primex, we were able to run 44. They said that helps a lot with lime usage, and then the temperature on your outlet controlled that a lot. And our winter months, we would set our temperatures lower to keep the lime usage the same, and then the summer months we would set it higher. So that's how we went about trying to conserve, be more efficient with our lime.
Okay.
And they said that also the baffles that we added in the recycle ash slurry tank to keep it stirred up better, they said that would also, Primex said that also would help with the efficiency of the lime.
Okay. All right, John, your thoughts on that?
I was going to say, recently at Logan, we did a lot of work on the dispersers, at the outlets of the finger ducts that come in and then swirl around before they come in. And what was happening to us up there, we were getting what we call wall falls. You have a lot of, I'll say, less mixed lime recycled slurry going in, and it tends to coat the walls, and then it flakes, then it falls off and it clogs up the outlets at the bottom, and jams up the fly ash system and all that. So it's a mess at times. Generally, if you back off the recycle to improve that, then of course you're going to spend more, in line. And if for any reason you lose the recycle flow, and this is at either plant, then you really need to take control of the temperature and raise your operating approach temperature up. Otherwise, you're gonna send a lot of wet ash, downstream, that's not reacting. So that the guys have I think they call it a drying curve that they're supposed to follow whenever they lose recycle for whatever reason. And it's just, that becomes one of those things that the operator really needs to be on the ball and, realize he has a problem and take that other action to change.
Okay. All right. Thanks, John. Rodney, you guys have any observations or done any analysis on those?
I'm probably not the best person to answer that question because I've been kind of out of the loop in the operations for a while, but I don't know that we've done any initiatives to purposely decrease our lime usage. Just we've kind of been in reactive mode for a couple of years where we're just recycle systems are bare, and keeping it running and keeping it in service and cutting down on the number of pluggages and stuff that we have. That's kind of been our focus, I believe. And I can't think any other initiatives off the top of my head.
Okay. All right. Thanks, Rodney. We're running down on time here, but I'm going to toss it over to Kurt for I guess one last question round.
Okay. Thanks. I was going to ask why nobody likes lime salesmen, why you keep trying to cut lime sales. But instead, well, I think you've all in your talks mentioned something about ash and landfills, and as much as you can comment, what type of initiatives are in place at your respective companies with regard to potential beneficial reuse of ash or ash minimization, or just handling the ash you're making as companies look to go more on the sustainability route? So it's kind of an open-ended question, but just what's on the horizon for you for that? And we'll start with Rodney.
We actually had our bottom ash analyzed, and our bottom ash is sellable, so it's marketable. So we've already we've been selling our bottom ash ever since we put our bottom ash dewatering system in service. The fly ash, for the most part, I believe is marketable, but I don't think the payoff was really there. We got the landfill. We don't create just a whole lot of fly ash, I guess, compared to other units. So right now we've been landfilling all of our fly ash. The fly ash from 1 and 4, specifically the 2 units that have the scrubbers, at least with the company that we were looking at that's using our bottom ash, has said that the 1 and 4 fly ash is not anything that they can use. So it's not even marketable.
Yeah, your other units, there's probably some potential there, right? But you don't have a whole lot.
Right.
All right. John?
Yeah, we have the ability to both treat the ash, we mix it with water. Of course, then you're paying a whole the water weight as well, but we also have the ability to put dry ash into a tanker. The ash hauling contractor has a responsibility for it, and occasionally he has a use where they'll take the dry ash and they'll mix it with concrete, make what they call flowable fill. They use it as a backfill material. There's not a huge demand for it, but they do use it on occasion. So it's kind of beyond us. Like, he's responsible for hauling the ash away, and it's occasionally say, hey, I'm going to need a couple of tanker trucks full of the dry stuff because they got a need over at another job site. So it's kind of up to them. It's really not anything we control.
Okay, thanks, John. Darryl?
Yes, sir. So when we first started out here, they said our ash was not marketable. And so we were landfilling everything. And then last year they come back and said, well, we think we found a market for it. So we installed the dry ash removal system. So far, we have not sold any or gotten rid of any, but we're hoping to soon. And I'll tell you one thing that I thought was neat that they come up with. If you have a landfill, you have to take care of it for years after, and keeping it mowed and making sure you don't have anything growing so tall on it. You know, they have installed AstroTurf on our landfill out here on one side. It's being tested. So you might look into that and see. So they're trying it. They haven't okayed it yet, but we have got AstroTurf on the landfill now.
That's interesting. That's interesting. All right. Well, thank you, Darryl. Thank you, gentlemen, for sharing your experiences today. We appreciate everyone's attendance. And Travis, you want to close?
Sure. Yeah, I echo Kurt's comments there. I mean, guys, we really appreciate you putting in the time to participate in this. Your feedback and your experiences is invaluable to those that are attending this. I also want to thank those that have taken time out to watch this, whether they're watching it live or if they're going to catch it on the YouTube channel, whatever, which this will be loaded up to YouTube within a couple days, and we will email everyone about that. I also want to thank Kurt and Mitch for your help with this. I mean, you know, it's a team. We do this together as a team, and you know, we couldn't make this happen if we didn't have each other here supporting one another. So thanks to everyone. At the end of this, you will see a survey come through from Zoom. I think it's actually when you hit the leave button, it should pop up. And once again, I ask that you complete that survey so we can have a path forward for 2022 with what it is you're looking for and what you expect. So thanks for watching. I wish everyone a safe day and a good week. Until next time.
Thanks, everybody.
See ya.
Thank you, Travis.